Well, aloha, and everything seems all dandy. And I'm going to finish up this mineral article. Under the contents here, we already swift through most of it. And where we left off is number 6 under classifications. We've gone through all the different classifications and two specific ones called silicates, two non-silicates. So those are the ones we have left, along with astrobiology, and then I'll look forward more articles related to what are minerals, how's it different from a gem, and when are we going to learn more about it. After all, most of the things about minerals has to do with how they're classed, what's the properties and such like that. Much harder to read, more to understand. Without further ado, let's leave up to non-silicates, but just silicates. I do wonder if I should go up here tomorrow. No. Yes, but nah, we should. This talks about some important people who separates the classifications of minerals and other related stuff like the animal and the plant classifications and how is it similar and how it's different, way different, that minerals should have its own classification tables. But anyhow, let's go with the silicates. The base unit of a silicate mineral is the teledron, tetrahedron. In the vast majority of cases, silicon is the fourfold or teledron coordination with oxygen. Yeah, it just tells a bit about this. This one looks a bit of phallic image. Agrin and iron sodium clinopyroxene is a part of a inosilicated subclass. Their silicon can are then polarized to be some degree to create various structures. Alrighty. Oh. That said, the degree of polarization can be described by both the structure form and how many tetrahedral corners or coordinate oxygens are shared. And then, to further ado, it goes through other properties. The silicate subclasses are described below in order of decreasing polymerization. Now we get to Tecoto silicates. Silicates, also known as the framework silicates, have the highest degree of a tetrahedral shared. The silicon oxygen ratio becomes 1 through 2. Examples are quartz, the felspar, falspathroids, and the zeolites. Zeolites, the framework silicates, tend to be particularly chemically stable as a result of stronger covalent bonds. Nitrite is a mineral series in the zeolite group. This is an example of very prominent auricular crystal habit. Looking at the shape and how is its structure, crystal habit. This. Feldspar are the most abundant group in the Earth's crust, about 50% in the feldspars. AI3 plus substitutes for Si4 plus. Yelpo. And it talks more further about properties. Yeah, we form the presence of water at low temperatures and pressures and have channels and voids in their structure. Zeolites have several industrial applications, especially in wastewater treatment. So at least I actually learned. Yeah. I didn't know that. Right. Let me see if I know anything more about here. Phyllosilicates. Phyllosilicates consist of the sheets of polymerized tetrahedra. They are bound at 3 oxygen sites, which gives a characteristic silicon oxygen ratio of 2.2 or 5. Important examples include the mica, chlorite and the colonite serpentine groups. And yep, it goes more here. In this case, the minerals term dicohydrate. Dicatihydra, whereas in another case is termed ticohytetra. The layers are weakly bound by van der Waals forces, hydrogen bonds, or sparse ionic bonds, which causes a crystallographic weakness, in turning leading to a prominent basal cleavage among the fissile silicates. Phyllosilicates. Okay, let's go there. As you can see in this picture, muscovite, a mineral species in the mica group within the phyllosilicate subclass. And what it looks like is a mixture of different structures being birthed in this base. But anywho, because of the chemical structure, phyllosilicates typically have flexible, elastic, transparent layers that are electrical insulators and can be split into very thin flakes. Micas can be used in electronics as insulators, in construction and optical filler, or even cosmetics. Yes. In silicates and silicates consist of the tetrahydra repeatedly bonded in chains. These chains can be single, where a tetrahedron is bound to two others to form a continuous chain. Gotcha. Amphipoles have a great variability in chemistry, described variously as a mineralogical garbage. Okay, sure. I know it's talks more about here. Well, let's go with cyclosilicates. Cyclosilicates or ring silicates have a ratio of silicon to oxygen of 1/3. 6-member rings are most common with a base structure of, yes, examples include the tourmaline group and beryl. Other ring structures exist with 3. Cycle tend to be strong and outweight. Then again, further, zolrosilicates, also termed disilicates, have tendril bonding. As you can see here, epidote often have distinctive pistachio green color. Let me position myself and see if there are any. I want to go through all these pictures because it just shows how wacky some of the properties can be and how they're pretty shaped to something that we see commonly in mammals, like this, the fact that it looks like white fur being grown. As asbestiform tetromolite, part of the Amphipolis group in the insulicate subclass. Doesn't explain much about it, but Oxygen group consists of 21 mineral species. Yeah, got that. Anything more? No, we should go down here. An example of albate, a species of tourmaline with distinctive color banding. Yes. 6-member rings are most common with the base structure. Examples: other ring structures exist with 3, 4, 8, 9, 12 have been described. Tourmalines get a very complex chemistry that can be described by its, yes, basic. Zolrosilicates. Yeah, we're now back to here. So, yeah, pistachio color. Let me see if they say anything about the colors around here. The resulting column structure. Okay. Epiphytes are found in a variety of geological settings, ranging from mid-ocean ridge to granites to metal pellets. Epidotes are built around the structure. Gotcha. Other examples of silicates include lawsonite and metamorphic mineral forming in the blueshite spaces. Orthosilicates consist of isolated tetrahedra that are Charge balanced by other cations, also term neosilicates. This type of silicate has a, yeah, it's typical. Okay, yeah, both iron and magnesium are in ultra by oxygen. Other orthosilicates include silicon, topaz, eos, and other stuff. Let's go back here. Black androidite, a member of the orthosilicate garnet group. But as you can see, the shape of it is being grown outward from a base. That's the way I've been explaining it. It's other. There's another way to describe it, which it's quite challenging to say because I could actually repeat with what I can just repeat what I reading, but no. I think the point is that it's hard for me to describe it from instead of just me knowing. Which brings the question if I really know it, I can't describe it in clear English or plain language. But that's the properties of understanding class and different classes of minerals, gems, rocks, ore, and all that stuff. Now let's go with non-silicates native elements. Native elements are those that are not chemically bonded to other elements. The mineral group includes native metals, semi-metals, and non-metals in various alloys and solid solutions. So solid solutions referring to the composition of a gem or mineral that is being formed up. Alloy, it's a property. It's hard to understand it, but think of something with metallicness. Read further here. Yeah, metallic bonding. Then it talks about the rest of the property, metallic ability, electrical conductivity, all that. The gold group with a cubic closed pack structure includes metals such as gold, silver, and copper. Native carbon occurs in two allotropes, graphite and diamond. The latter forms at a very high pressure in the mantle, which gives much structure. Alright, sulfides or sulfate minerals are chemical compounds of one or more metals or semi-metals within a chalcoine limestone, which is sulfur is most common. Alrighty. We're gone through native metals. Let's go with sulfur. So it's related to this. Understand that it's a non-metallic. And it's a native metal, but it's treated differently. Red cannabar, a mercury ore, or on dolomite. Selenium arsenic and selenium can substitute for the sulfur. Sulfates tend to be soft, brittle minerals with a high specific gravity. Alrighty, sulfides are classified by the ratio of metals or semi-metal by sulfur, such as Ms equal to 2, 1, or 1, 1, referring to how the chemical composition creates sulfur minerals. And how they're compromised. After all this white stuff usually in gemstones or ores are part of the chemical composition. Think of it as birth residue. Now, shall we go down here? Yeah. Related to the sulfides are the rare sulfide salts in which a metallic element is bonded to sulfur or semi-metals such as antimony, arsenic, or bismuth. Like the sulfides, sulfur salts are typically soft, heavy, and brittle minerals. Alright. Things like that. Now let's go with oxidides. Oxide minerals are divided into three categories: simple oxides, hydrous oxides, and multiple oxides. Simple oxides, keratosis. Okay, yeah. Then goes chemical composition, how to differ what they are. Yes. Yeah, all the way here. I mean, in the last sentence, it just doesn't say any more further. The latter and the readily distinguishable by the strong magnesium, which occurs as it is an iron in two oxidation states with chemical formula, which makes it a multiple oxide instead of a single oxide. Alrighty. Well, the gist is you understand that oxides, unlike native elements, require a lot of chemical composition. And now we're to halides. The halidide. The halidide minerals are compounds in which the halogen, fluorine, chlorine, iodine, bromine is the main ion. These minerals tend to be soft, weak, brittle, and water soluble. Common examples of halidides include halite, solvite, and fluorite. Yes, there's more of it, but yeah, just gonna go through here. Pink cubic halides crystals on the nitric matrix. Alrighty. Use baking soda, so you'll understand that it's part of halidides along with this. However, as the only significant occurrence at Levitut, Greenland, in a graphite pigment was depleted, synthetic chrolite can be found from fluorite. It's a natural made one that can be found in nature, most commonly in some areas like Greenland. And that's a cold place. Carbonates. The carbonate minerals are those in which the main iodide group is carbonate. Carbonates tend to be brittle. Many have from hydrochlorous and all react to acid. Alright. The most common carbonate mineral is calcite, which is the primary constituent of sedimentary limestone and metamorphic marble. Calcite is in regard depending on which mineral preferably forms. Along with these two mineral species are members of an anomalous mineral groups. Okay, the calcite includes carbonites. Yeah, okay. Then it talks more about the chemical formulas and chemical compositions as usual. But anywho, the point in carbonates is that, well, they're carbonate minerals because they're part of a group and they have a specific chemical composition. And yeah, that is very just of it. I don't want to go any further. Now we're in sulfates. Sulfate minerals don't include the sulfate ion. They tend to be non-transparent and translucent, soft, and may be fragile. Commonly form as evaporates. Alright, then now it's going to talk more about the properties. But anyhow, this image on the right-hand side that looks like a pair of leaves is gypsum desert rose. And they're pretty sensitive. They're fragile to the point that they could be just a crusted old leaf and not a hard mineral like diamond. But yeah, I've not seen these before. And to a point, it actually looks pretty. Real pretty. Sulfates can be subdivided in hydrols and hydrous minerals. Alrighty. Yeah, conductivity, then the rest of the properties. Now, phosphates. The phosphate minerals are characterized by the telutride unit, although the structure can be generalized, so phosphates can be replaced by autonomy, arsenic, or vanadium. Alright, then just tells you some facts related to it, but understanding that, yeah, the phosphate minerals are just categorized by the unit of the formula, and the structure can be either generalized or has some properties like this one. Phosphorus is replaced by antimony, arsenic, or vanadium, so other minerals and its properties interacting with it. Now let's go to organic minerals. The strongest classification includes the class of organic minerals. These are rare compounds containing organic organic carbon, but that can be formed by a geological process. For example, welvelite, this formula is an oxalate. Alright, well, hydrocalcium, okay. and it's not considered related to biological activity. So it does show that with organic minerals coming into the frame, to minerals and classifications, they're adding it as a subclass, something additional like the periodic table, and that goes to show how following all this stuff can be more like just having a bunch of spreadsheets and marking down which is which. Recent advances, mineral classification schemes, and they're evolving to match recent advances in mineral science. So that's one big reason why it's expanding, because there's more discoveries and new ways to classify things to make it not easier, but to make it more accurate and to stamp out all the properties of specific minerals. Dynamic Commission, new minerals and mineral names adopted in 2000. Yeah, as we went through here a few streams ago. According to these rules, mineral species can be grouped into a number of different ways on the basis of chemistry, crystal structure, occurrence, association, genetic history, or resource. Okay, and that's pretty much it. Now let's go with astrobiology, because I heard about it, don't know much about it. It's been suggested that biominerals can be important indicators of extraterrestrial life, and thus could be playing an important role in the search for place and life about Mars. Okay, let me actually see. Yeah, this actually is something easy to comprehend. So let me read this in my one of my voices. Astrobiology. It has been suggested that biominerals can be important indicators of extraterrestrial life, and thus could play an important role in the search for past or present life on Mars. Furthermore, organic components, biosignatures that are often associated with biominerals, are believed to play crucial roles in both prebiotic and biotic reactions. In January 2014, NASA reported that studies by the Curiosity and Opportunity rovers on Mars would search for evidence of ancient life, including a biosphere based on autotrophic, chemotrophic, and or chemical lithoautotrophic microorganisms, as well as in ancient water, including fluvial-lacustrine environments, plains related to ancient rivers or lakes that may have been habitable, to search for evidence of habitability, toponymy. Oh man, I can't read with this accent. Taphonomy. Taphonomy related to fossils or organic carbon on the planet Mars became a primary NASA objective. So that is astrobiology. Astro is referring to space, like astronomy or astrology. That's a great word to know about whenever you hear astro in science. But yeah, it does refer to understanding what other minerals can exist on other platforms. Curiosity and Opportunity referring to those rovers that operate around Mars that gave a lot of intel evidence on living life, potential life in Mars. And this is something that does grow more, along with understanding about gems, minerals, ores. That's part of the growing field. And now we have finished all the way here. Now let's see if we go through. Agro minerals, not something too specific, but amateur geology. That's something I could briefly cover. The list of minerals, I want to skim through to see if in this list of minerals actually has pictures, so I could showcase so much of the variety that minerals, gems have. Just it. Now there's minerals and nutrient and mineral evolution. Well, I am curious with mineral evolution. Increasing minerals diversity over time. I wonder if it's distinctly related. Now minerals and nutrients, that is different. Where it does follow another science. Human anatomy, human science. So I could go through there enough time, especially since I like to learn about fitness a long time ago, and I still want to showcase that in depth. Now let's go with list of minerals if I can skim through. Alright, so this one is all listed in alphabetical order. Aquamarine, Alpha White, Arsene Flump White. I saw that before. All these colors. I'm not gonna pronounce all these, but yeah, they have it on here under A and B. They only have a listogram. I'm gonna just keep on scrolling. Sky blue, pocket cavity of a small cryos kind. Sky blue, prismatic crystals of cellophane from the okay. Sky blue. Huh. Yeah. I mean, looking at prismatic colors in different light just showcase the colors. That's the beauty of it. You got emerald, you got F, and so far, so forth. You got. Ooh. Followed by blue. It looks like a dark blue. Navy. Yeah, it's like pistachio ice cream, but something that's rocky and icy. There's the grass. And yeah, you have the rest of other. But yeah, this goes to show how every minerals is under its a list of content. And it's just no point to understand it, just to use it. Now, amateur geology or rock collecting in the United States is a non-professional study and hobby of collecting rocks and minerals or fossil specimens with a natural environment. In Australia, New Zealand, and Cornwall, the activities of amateur geologists are also called fossil slicking. The first amateur geologists were prospectors looking for valuable minerals and gemstones for commercial purposes. Eventually, however, more people have been drawn to amateur geology for recreational purposes, mainly for the beauty that rocks and minerals provide, along with having some in their own collection. And, if you want to make it a jewelry and give it to a significant other. And, it's just like picking flowers. And give it to someone. It's a great gift. Now let's go with mineral evolution. It's a recent hypothesis that provides historical context in mineralogy. It is postulates that mineralogy are plants and that moons become increasingly complex as such a result of changes in the physical, chemical, and biological environment. Yeah, well, this goes to not just theories, but also other things related to it. But first, I gotta go through, gems, ores, rocks. Further ado that. Okay, a rock. Let's see what it comes through. Yeah, gems, cool. Ores and gems. Alright, this is all stuff that I can go through and briefly go through next time. Anywho, aloha.